Welcome to the world of infrastructure wonders, where massive concrete bridges connect the most distant lands.
To build a structure weighing millions of tons in mid-air, engineers must conquer the limits of gravity and terrain.
Each bridge span is more than just concrete and steel. It is a complex physics problem, calculated to the nearest millimeter. From deep abysses to vast straits, modern bridge construction is a symphony of strength and human intelligence.
The secret lies in pre-stressed concrete technology, allowing long spans to stand firm without middle supports. At the heart of this process are the massive girder launchers, steel monsters that walk through the air.
Before the first ton of concrete is poured, the entire assembly process has been simulated thousands of times digitally.
Safety is the absolute priority, where every variable of wind and vibration is monitored 24/7 by smart sensors.
Logistics is a colossal challenge, as components weighing hundreds of tons must be delivered with surgical precision.
An error of just 1 millimeter at the base can lead to disaster at great heights. Precision is the engineer's creed.
We begin at the foundation, the invisible but most critical part of every great bridge. Steel piles are driven hundreds of meters into the riverbed to find the most stable geological anchor point. Thousands of cubic meters of high-grade concrete are poured continuously to create solid board pile systems. Even in the depths, specialized robots work tirelessly to inspect every detail of the foundation. This massive concrete cap will bear the entire weight of the bridge piers and the spans above. Climbing formwork technology allows bridge piers to grow day by day, automatically and continuously.
Inside each pier is a dense network of reinforcing steel, woven together like industrial muscles. Once the piers are ready, the stage is set for the performance of the girder launching machines.
These specialized bearings allow the bridge to expand and move flexibly under varying weather conditions.
Now, let's visit the factory where the massive bridge segments are cast with absolute precision.
Welcome to the precast yard, where bridge segments are mass-produced in a controlled, industrial environment. These massive steel molds are designed to produce segments with a tolerance of less than 2 millimeters. Automated robots handle the rebar bending, ensuring every piece of steel matches the digital blueprint perfectly. The steel backbone of the segment is lowered into the mold gently by massive industrial gantry cranes. Pre-stressing cable ducts are positioned now. This is the key to the concrete's future strength. High-performance concrete is poured, combined with high-intensity vibration to eliminate all air bubbles.
The steam curing process allows the concrete to reach its maximum strength in just 24 hours.
As the mold opens, a perfect bridge segment is revealed, ready for the most rigorous challenges. Each segment has its own unique ID and birth certificate to control quality throughout its life cycle. Specialized transport vehicles move these 100-ton components as if they were giant chess pieces. The joint surfaces are designed with a shear key pattern to ensure perfect alignment during assembly.
Ultrasonic waves check the uniformity of the concrete, ensuring no internal cracks exist.
This yard holds thousands of tons of material, ready to be transported to the active construction site. Multi-axle trailers with hundreds of wheels ensure the segments do not vibrate during transit. Smart hydraulic suspension systems keep the segment perfectly level, regardless of the terrain.
As the first segment arrives, the mid-air assembly process is officially ready to begin.
Anchor points are checked rigorously. This is what will bear the full load when lifted into the sky. Massive electric winches begin to rotate, preparing for a historic lift into the clouds.
Centimeter by centimeter, the massive concrete block is raised hundreds of meters into the air.
The segment has reached its destination, and now the steel monster is ready to perform its duty. Behold the launching gantry, a machine that allows bridge construction without ground-based scaffolding. This machine is capable of walking to the next span by pushing its own hydraulic legs forward.
It moves slowly and precisely, hovering over the abyss like a giant mechanical steel spider.
Every movement is computer-controlled, monitoring tilt and center of gravity continuously.
After lifting the segment, the machine carries it along its own body to the exact installation point. A specialized layer of high-strength epoxy resin is applied to the joints for waterproofing and bonding. Immense hydraulic pressure squeezes the two segments together, turning them into a single monolithic unit. High-tensile steel cable bundles are threaded through all the segments of the bridge span. This is the post-tensioning process, a technique that enables concrete spans to withstand immense bending loads. Steel anchors lock the cables in place, permanently storing the tension within the concrete. One bridge span is complete. The machine prepares to step to the next pier to continue its journey. The guide nose extends into the air, searching for an anchor point for the machine's next step. Precision to the last millimeter, the machine has established a bridgehead to push itself forward. Mobile counterweight systems ensure the machine does not tip while reaching out for the next support. The cycle begins again. This is the most efficient mobile bridge production line in the world today. A continuous supply of materials is vital to ensure the construction progress remains on schedule. Cable tension must reach absolute standards to guarantee the load-bearing capacity of the span. After tensioning, cement grout is injected to protect the cables from corrosion and increase bonding.
The bridge is slowly taking shape, stretching across the valley like a powerful gray ribbon.
With this technology, we can build dozens of meters of bridge every day on any terrain.
Even curved bridge sections are handled smoothly thanks to the flexibility of the launching gantry. These fine adjustments ensure the entire bridge will fit together perfectly at the final meeting point.
Construction mid-river requires strict environmental protection and erosion control techniques.
Steel joints are welded automatically to ensure maximum durability and high aesthetic finish. The box girder design reduces weight while maintaining extraordinary structural rigidity for the bridge.
Inside the bridge's heart is where the technical systems for operation and maintenance are housed. Every tiny detail is checked and tightened according to international technical standards. The smart bridge is equipped with sensors to monitor structural health in real time. The work never stops. Bright lights illuminate the tireless efforts of the engineering teams.
This is a testament to human intelligence, conquering nature through modern technology. Besides girder launchers, the balanced cantilever technique allows for the construction of record-breaking spans.
Formwork travelers push themselves further away from the pier, casting new span segments in mid-air.
Concrete is transported up and poured directly into the mold at the precise installation location.
Balance is survival. Weight on both sides must be controlled to prevent the pier from collapsing. The moment two spans meet in the middle is the pinnacle of engineering precision. Joining the bridge is the most important event, marking the continuity of the entire structure.
Joy erupts as the efforts of hundreds of people are rewarded with a perfect connection.
From scattered pieces, a path in the sky has officially been formed. The bridge can now stand on its own feet through the power of post-tension concrete.
The raw concrete surface is now ready for finishing to become a modern highway.
A layer of modified asphalt is applied to protect the concrete and ensure a smooth ride. The paving process is carefully executed to avoid overloading the center of the spans. These expansion joints allow the bridge to move flexibly during sudden temperature changes. Joints are sealed to prevent water and debris from falling onto the bearings below. Before the grand opening, the bridge must withstand the real weight of dozens of heavy trucks. Engineers monitor deflection and stress to ensure everything remains within safety limits. Every structure has elasticity. The bridge is proving its resilience against the ultimate test.
Safety certification is the final step for the bridge to officially serve the community.
A shimmering beauty that transforms an engineering project into an architectural work of art.
Connection is complete, opening up trade and development opportunities for an entire territory.
Protecting the pier base from erosion is vital to ensure the bridge lasts for generations.
Periodic inspections using diving technology help detect early signs of erosion.
Unmanned aerial technology allows access to difficult areas quickly and safely.
Renewable energy is integrated to power the bridge's smart monitoring systems.
Maintenance is the key to keeping steel components resilient against the test of time. Specialized protective coatings prevent oxidation, keeping the structure looking brand new.
These specialized devices allow engineers to inspect every corner of the massive structure.
Every tiny detail is cared for to ensure the bridge operates perfectly for the public.
Safety and reliability are the greatest gifts engineers provide to every driver. Cable-stayed bridges represent another pinnacle, combining grace with the raw power of steel. Thousands of tons of tension converge here, holding the bridge deck aloft in the air.
Automation technology permeates every maintenance step, ensuring no errors occur.
Damping systems help the bridge neutralize vibrations caused by high winds or heavy traffic.
An awe-inspiring perspective, showing the vast scale of structures humans can create.
Regardless of harsh weather, the drive to connect humanity pushes us forward.
Concrete heating technology ensures structural quality is not compromised by freezing temperatures.
The rhythm between water transport and heavy lift engineering is a delicate art. This precise alignment is the result of months of meticulous measurement and fabrication.
Every bridge marks a new chapter in the history of human infrastructure development.
Intelligence and data are the foundations for the safety of millions crossing every day.
The final touches bring aesthetic beauty and peace of mind to the users.
Modern engineering always aims for sustainability and respect for the surrounding environment.
Surface water treatment systems ensure road oils never flow directly into our rivers.
The modern bridge is a multifunctional space for all modes of travel and connection.
The end of a bridge's life cycle is just the beginning of a new engineering miracle.
Material circularity is an essential trend in modern infrastructure construction.
The future of bridge construction is being shaped by 3D printing and smart materials. New materials help us build longer, lighter, and more durable spans than ever before.
New horizons are opening up thanks to the courage and brilliance of young bridge engineers.
These structures inspire the next generation to follow in the footsteps of engineering.
Recognition for the silent efforts behind these miracles of concrete and steel. A feeling of freedom and convenience, turning the impossible distances into a simple path.
The harmony between man-made architecture and the natural beauty of the world. Each bridge is a brilliant mark of civilization on the global map.
Automation technology closes the loop from construction to smart operation. Your support drives us to continue showcasing these technical wonders of the world.
The journey to connect the world will never stop, as long as we dare to reach further.
Subscribe to stay tuned for more incredible engineering stories on our channel.
The bridge of the future is ready. Thank you for watching.